Let's investigate the measures of the three angles of a triangle. If vertex A is moved down toward side BC, what will happen to the measure of angle A? What will happen to the measures of angles B and C? As vertex A moves down towards BC, the measure of angle A increases, and the measures of angles B and C decrease. Describe the measures of angles A, B, and C when the vertex gets very close to side BC. As vertex A gets very close to side BC, the measure of angle A gets very close to 180 degrees, and the measures of angles B and C get very close to 0 degrees. In the limiting case, A is on side BC, and the triangle collapses into a segment. Then the measure of angle A is 180 degrees, and the measures of angles B and C are both 0 degrees. So the sum of the three measures is exactly 180 degrees. Can you think of a location for vertex A where the measure of angle C would be very large and the measures of angles A and B would be very close to 0? As vertex A swings around to the left like this, the measure of angle C gets close to 180 degrees, and the measures of the other two angles get close to 0 degrees. In the limiting case, points A, B, and C align, and the triangle again collapses into a segment. Then the measure of angle C is 180 degrees, and the measures of angles A and B are both 0 degrees. So the sum of the three measures is exactly 180 degrees. There is another interesting special case to consider. Let's form an isosceles triangle. Notice how the measures of the angles change as side BC shrinks. Describe the measures of angles A, B, and C when vertex B gets very close to vertex C. When vertex B gets very close to vertex C, the measure of angle A is very close to 0 degrees, and the measures of angles B and C are both very close to 90 degrees. In the limiting case, the triangle collapses into a segment. The measure of angle A is 0 degrees, and the measures of angles B and C are each 90 degrees. Again, the sum of the measures is 180 degrees. Here is another way to think about the angles of a triangle. We can draw a line through vertex A which is parallel to side BC. Notice that these two highlighted angles are alternate interior angles formed by parallel lines. Therefore, they are congruent. Notice that these two highlighted angles are also alternate interior angles formed by parallel lines. Therefore, these two angles are also congruent. No matter how the shape of the triangle changes, the two pairs of angles are alternate interior angles formed by parallel lines, and therefore they remain congruent. Since these three angles form a straight angle, their sum must be 180 degrees. How does this show that the sum of the measures of the three angles of a triangle is 180 degrees?